I'm uploading my first task given by Spark Foundation. Here we have to predict percentage of marks of student based upon the number of hours of studies. I'm using tool Python and I'm using software Jupyter notebook. This is a simple linear regression problem. For that, I'm importing all the libraries using this notebook. I'm using the pandas for the data handling. I'm using the numpy for the number handling, and my matplotlib.pyplot as PLT for the data visualization. First of all, we have to read the data. For that, we will use bd.readcsv, and we will check the data whether it is imported successfully or not. We'll check the shape of the data also. There are 24 rows and 2 columns only, and info of the data types also, for seeing the values are non-null or null. Here data is almost the clean non-null values. Then we will see the data dot description. For the numbers, the mean of the scores are the 51%, and the minimum of the scores are the 17%, and the maximum the scores are 95%. And now we will see the data visualization, because here are the two variables and the both of them are numerical. So best visualization is the scatter plot, and we can clearly see that there is a strong positive correlation between the two, because the number of as much number of hours a student studies, he will get the good marks. And now we will prepare the data itself, and we are logging the data because we have the two variables only. So as Python index starts from the 0, so we are taking all rows and the -1 column, so that the first column can be included in the independent variable. So we are splitting it into x and y, and now we will split the data set, and for that we will recall the model from sklearn.model selection import train test split. Now, and this split is we are taking 80-20%, 80-20 ratio. Training the algorithm. Now it is time to train our algorithms. So we will call the model now, and we will store it in a variable regressor, and we will plot the regression plot also. Now we can see that the variables are uh, linearly correlated with each other, and this is the best fit line. Here the error is the minimum error here, so this is the best fit line for the regression. And now it's time to make some predictions. So we are testing data. These are the probabilities, and comparing actual versus predict. These are the actual values, and these are the predicted one. And you can also test with your own data. Own data means whatever the number of hours, 9.25 hours we have to predict how much a student will score. So this is the prediction. 93.69% student will score if he is starting for 9.25 hours. Now it is time we also check the evaluation of the model, how good our model is. So we are getting the score at this. These are the accuracy score actually. Regresses.score on the train set. This is 95%, and on the test data also it is 95% almost, because this is a very good model actually. And we are also getting the RMSE scores. RMSE scores is root mean square error, and it is actually assumed that minimum the error is, the better the model is. So here we are getting RMSE score 4.64 and mean absolute error 4.18. So this is a very good model in all. So now the conclusion is there is a strong positive correlation between the score and the number of hours of the student studies. Thank you.